Welcome to video 2 of chapter 3. And we will look at various data collecting methods and measures, beginning with observations. And there are two basic types of observation methods. The first is laboratory. No, sorry, let me start with naturalistic observations. The second will be laboratory. Naturalistic observations are when you go in the real world to observe behavior as it naturally occurs. So it's got the advantage that you're capturing naturally occurring behavior, and you could do studies where people don't realize that they're being observed, or that they don't realize that they're being studied at all. One example that just comes to mind is there was a study conducted in a science museum, and I mean, the public that was entered in the science museum, they were made aware that there were cameras and recording devices, throughout the science museum. Just and that the data may be studied for scientific purposes, and so it wasn't. They were originally made aware of this, but it wasn't like it was in their face or anyone was following them around. There was like cameras kind of all hidden away here and there, and recording devices. So people behave very naturally. They don't walk around thinking, "Oh, somebody's listening to everything I say." I mean, they just knew that there was, there's lots of places we go in public where there's cameras and recording devices. So what they did in the study, so we can expect behavior was very natural, and what they were interested in is they recorded like how much parents or what type of explanations parents gave their male children versus their female children when asked questions about exhibits and things, and they found that the parents gave much more scientific oriented explanations to their male children compared to their female children. So this was a fairly straightforward naturalistic observation, and it showed that parents generally have different expectations for their male children versus their female children as far as their scientific knowledge. And in a laboratory observation, we control the conditions and invite people into what we call a laboratory setting. And a lot of people think right away when you say laboratory observations, they think that you're necessarily inside a room, a laboratory. I mean, laboratory, it just means controlled conditions. So let me give you an example of what I mean by that. I mean, when I talked about observing children in a playground, so let's say I'm really interested in studying aggression levels among 5-year-olds, you might think, well, you would use naturalistic observation and just watch children as they naturally go and play in the playground and watch for levels of aggression. But remember, I'm interested in 5-year-olds. I mean, I have no control over a public playground. There's going to be teenagers there and older children and younger children, and there's going to be parents getting involved, and it's like I won't know right away which children are 5 or which ones are a little bit older or younger, and there's absolutely no control. Like, so when I see aggression, and the children might be of different ages, and might be a 7-year-old picking on a 5-year-old, and it doesn't really answer my question. And so because of the lack of control, that would be a horribly complicated experiment to try in any kind of naturalistic setting. So you would actually invite them to a playground laboratory, and there's a number of universities that have playgrounds set up at the universities for these purposes, to study children in a natural playground setting. And so these are not open to the public. You can invite exactly the number of children you want, exactly the right ages. You can have the parents, stay back, maybe behind a certain line or behind a fence, or or just observe from behind windows. And you can have cameras recording the behavior on the playground, so you don't have to be standing there with a clipboard. And so it can be very well suited and with high tech equipment and whatnot. But for the children, it's just going to be a playground. It's an outdoor playground, and even though there's some hidden cameras around and things like that, but so in a sense, you're getting natural behavior by the children, but it's a controlled setting, and so that would be called a laboratory observation. So don't always think like, oh, you're in a scientific laboratory. A laboratory study could be done in a parking lot where you're testing, I don't know, driving and cell phone use. And so it's a controlled condition when you set up some pylons, you have people, talk on their phone as they drive around. So that would be called a laboratory observation as well, because you control the conditions. Okay, so that's I keep mentioning the word control. That's the advantage of laboratory observation. You get to decide exactly how things are set up, who participates and who doesn't. But obviously you're sacrificing some of the natural, naturalness of the experience. People that come to experiments know that they're in an experiment. They know that they're being studied or tested on something. So it might affect their behavior, knowing that people are recording them and things like that. One thing that we have to be careful of in either case, naturalistic or laboratory observation, is what's called observer bias. And this comes about when if the observer that's recording behavior, if they know what the hypothesis of the study is, it can affect their observations and how they record them. And I'm not saying anyone, any researchers are purposely cheating or anything, but we know from psychological study that it affects people. Just if you know the hypothesis, it affects you on an unconscious level. And so, maybe, there's an observer witnessing 5-year-old girls and boys in a playground, and they're keeping track of aggressions, and he sees this girl, Sally, come up, and she kind of like waves her arm towards Billy, and like, kind of like a striking motion. She doesn't come that close, but you might be saying, oh, that looked aggressive to me. And then like a half an hour later, Billy comes up to Sally and does the same kind of thing, and your mind just kind of sees it a little bit different. Well, you know what? He was kind of just shooing her away. It didn't seem aggressive to me. And this would not be purposeful, but you actually, if you know your hypothesis, it affects how you perceive things. So, and this is once again true in naturalistic or laboratory observations. So we experimenters always keep that in mind. You would hire people that do not know the hypothesis. They're simply recording behaviors. They have no idea if you're looking for, male versus female behavior, or you just want the total number. So you make sure that they are unaware, and you just train them on what to observe for. Okay. And this is true of almost any kind of thing, like in drug studies. The people that, let's say you're in a drug study and you go in and somebody's measuring your progress, maybe I don't know, you're in a study where you're taking a new weight loss pill, and anyways, the person that's going to record your weight when you come in, they're not going to know what condition you're in. They don't know if you're in the placebo condition or if you're in the actual drug condition. They would have no idea. Anyone that actually works with the subjects is unaware of who's in which conditions. And somebody at the top that knows these things, doesn't work with the patients or the subjects, I should say, or clients. Okay, self-report measures. This includes surveys, questionnaires, interviews. Basically, I mean, people are being asked questions, and they're self-reporting, about their own behaviors or their own thinking or emotions or whatever it is that you're interested in asking. And this is the advantage, the major advantage of self-report measures is it's easy, it's quick and easy, and a cheap way to get a lot of data. I mean, I could put a survey on the internet, maybe get thousands of responses. I mean, like, it's not costing me anything. I'm not inviting people into the laboratory and paying them money. Like, maybe I offer like a gift card to, one out of every 50 people get a gift card. I mean, whatever, and people will respond. Um, with the internet, it's obviously even easier than it used to be, but it used to be that you would mail out surveys. Like, if I'm interested in the U.S. population, I could mail surveys all across the U.S. just for the price of a stamp, for each one. I could mail out 10,000 surveys. I won't get them all back. I could ask people nicely, please fill this out, return it, but I'll get a lot of them back. And it's like, I'm really not doing much work, besides the initial mailing to get the data. So really cheap, easy method to get a lot of data compared to, unless you're doing interviews, that's obviously much more time consuming. And the major disadvantage of self-report measures is what we call socially desirable answers. And people often will answer questions about themselves with answers that put themselves in a good light. No one likes to admit to, things that are negative about themselves, or if they feel like they're negative. So if you ask any kind of sensitive questions, and you know that not everyone is going to be completely honest and truthful, you will get some people, you know, um, given these socially desirable answers. This is why, for instance, for the longest time, I mean, no one's ever had a real accurate measure of what the gay and lesbian population is in the United States, because you can't do a survey without some people. You always know there's some people that aren't necessarily telling the truth or being accurate, because they may be, some people may be ashamed, or they, especially when there was more of a stigma around the issue. Um, some people don't want to admit it to themselves, or and so like it was always, when surveys were conducted, we always knew that the results that were obtained were lower than actual figures. If you ask about people's drinking behavior, drug use, smoking behavior, um, or anything like that, like any kind of sensitive issues, people don't give the exact right answers a lot of the time. Yeah, and it's not always that they're trying to lie. Even um, I had an experience with my doctor, and I was trying to be honest. And after I left the doctor, I realized I I kind of like downplayed a couple of the numbers when he was asking questions about certain behaviors. This was years ago, but and I was trying to be honest, but it's just we like to make ourselves feel better. No one wants to admit, like, you know, I drink this much, or I smoke this much, or I do these drugs, and it's like you might be trying to be honest, and you kind of give part of the truth. Okay, if the questions are really mundane, then there's no reason to expect that the answers will be inaccurate. Of course, there'll be a small percentage of people that just fool around and purposely try to mess up the survey or something. But often we can detect those. There are ways to kind of notice when somebody purposely, um, I'm just going through the survey, not even like reading the questions. I mean, so you can put little traps in the survey where the two answers should be the same if they've read them, but if they haven't, they might put different answers, things like that. Uh, but you can expect they're much more accurate. Okay, let me go on. Now, standardized tests. These are things like, IQ tests or standardized tests. I mentioned in the last video, SAT tests, ACT tests would be in the same ballpark. We use standardized tests like the SAT or the ACT. As I mentioned in the last video, we know it helps to predict college GPA. So it's very useful to collect SAT data. This is why we put high school students through that, because we want students that we know that we figure can pass, um, the subjects at our particular college or university. And so we this is why different colleges or universities require different benchmark SAT scores, because there's no use inviting somebody to your school if you already are predicting that they're going to fail out. Okay, let me go on. Next we have physiological measures. So physiological measures, you're recording, some kind of biological measurement. I mean, this could be as simple as recording somebody's heart rate or blood pressure. Galvanic skin response gets used sometimes. You can kind of pick up if somebody's very nervous with that measurement. And it's similar to what they use for lie detectors. There's also measurements of that involve the brain. And one of the nice things about physiological measures and recording brain activity is that you can gather data that doesn't require language, and it doesn't require so I'm trying to read my notes here. It doesn't require an active response, or language or an active response. So it's can be very useful for infants or young children. You can make recordings of an infant that you can't ask them what they're feeling, or you can't ask them, are they thinking of something? I mean, like, you can get ideas of what's happening in their brain by doing physiological measures. So a couple of examples that can be used with very young children or infants are EEGs and ERPs. Let me go through those now, and I'll just mention a few different types of scans. EEGs are one of the older scans that are around. It measures the electrical activity in the brain. EEG stands for electroencephalograph. It's like you've probably seen the output before. It's like a wavy line, up and down wavy kind of line. Very useful in sleep studies. You can see the cycles of the brain as a person sleeps. You can tell when they're dreaming, for instance, based on the EEG reading. Anyways, EEGs are often used in ERP studies. ERP. This stands for event-related potentials. And this is when you measure the brain's electrical response to meaningful stimuli. So you're not just measuring the brain like while they're sitting there, like you're actually testing them on presenting stimuli to them and seeing how the brain electrical activity changes in response to stimuli. So it might be stimuli like you might be playing music, different types of music. You could be exposing them to different languages. You can expose them to different moods, people yelling or people crying, and see how the brain responds. You could show pictures or videos and see how the brain responds to me. So very useful. And you can do this once again. These EEGs and ERPs are used with, in the first year of life with babies. They have specialized, kind of skull caps that you can just place over the baby's head that has electrodes around it, and so you can measure. They don't have to sit perfectly still. They can kind of move around it. It stays on their head, and so it can be used with babies. fMRIs are one of the newer scanning techniques. fMRIs stands for functional magnetic resonance imaging. And this is this particular machine, and it's pretty incredible, but it measures blood flow in the brain. It records like different amounts of blood flow in the brain to show which parts are active at any time. So any part of the brain that you're using would have more blood flow in it. And it's very sensitive. I mean, so it records, exactly like down to kind of like the smallest brain areas. Like you can see, is this right here? Is this little tiny area active or not? And anyways, this is not used with young children. This is one that does require you to be to remain very still, and young children are not very capable of that. So fMRIs are not used with them, but for older children or adolescents, it can be a great measuring device. I mean, it's actually showing you like the EEG is just kind of showing you electrical activity, like waves, and this is like telling you, oh, the look, the hippocampus is active at this point, or the you can see that the prefrontal cortex has a lot of activity while they observe this while they're observing I don't know this movie, or I mean, like, it just, you can see specifically which brain areas are active at any point, and how they change over time. Okay, anyways, those are a few different, just a few examples of physiological um, methods used to study the brain. Next, we have archival records. This is when you use pre-existing data. Okay, so existing records to study something. This could include things like government statistics, like you could use census data, for instance, and just compare, is there a relationship between education level and, I don't know, income in a family? And you would expect yes. I mean, that's not a real difficult question, but you could see how closely they're related. Are people that are more educated, are they really making more money, and how much more? And census data would provide that kind of thing. You could compare different sized families and see if that affects, I don't know, income level, for instance. I don't know, or education level. And there's a lot of data just from the census that the government does. Police reports sometimes get used. Medical records can be very useful. School records, sometimes you can get a hold of transcripts for people you're studying, and they give their permission. And so, like any existing records, and then you're kind of looking in the past. So you don't even have to have active subjects. You're using data that's already out there to study something. Okay, next we have case studies. Um, Case studies are interesting. In any in almost any typical study in psychology, we like lots of subjects. In fact, I mean, it's your experiment is considered better if you have more subjects. So when I ran experiments, I typically had hundreds of subjects in each experiment, because you kind of get more power in the experiment if you have lots of people in it. So why would we ever just study a single individual, or just a very small number of individuals? And this is what case studies are. It is the extensive study of a single individual or a small number of individuals. And the reason that this is done is in some cases there is only one individual that has a particular condition or a particular injury, like a particular type of brain injury, or there might only be a few people that have a particular condition or disease. There are some diseases in this world that affect less than 12 people, like less than a dozen people worldwide. They're so rare that if you can find a few of them to study, I mean, like, you try to study those individuals extensively, like, while you fly them, if you're going to fly them in, let's say, to study that rare disease, you're going to try to study them, for quite a while, and then learn as much as you can. When I talk about single individuals, there examples are like Phineas Gage, like 100 years ago or so, and he was a railroad worker, and he was tamping down some dynamite or black powder or something, like, with a big, railroad spike. It's like a big long metal pole. Anyway, so the blast went off, and the pole went up through his cheek and through his brain and out the back of his skull. And so this long pole, about 3 feet long, went all the way through his hand. And anyways, they studied him. Is an interesting case study. They didn't study 10 of him because there was only one. So anyways, his personality changed and stuff. There was Sybil. She was the woman that had like over 20 multiple personalities. That's a lot. It's very rare to have that many. So she was extensively studied. HM went for an operation in his late 20s, and they took a piece of his hippocampus out. And he lost the ability to form new memories for the rest of his life. He could never remember anything for more than 30 seconds after that. So every day, he'd wake up still thinking he was like 27 or 28, or it was around there when he had his operation, even if it was 10 or 20 or 30 years later, because he had no memories ever since that operation. He had no new memories. He could remember everything from before, but anyway, so interesting person. He was studied for years and years and years because he didn't get bored, because he always forgot that he was studied. And anyways, and we learned so much about memory from this one individual. Anyway, so these are case studies, interesting people that have some rare injury or behavior or condition or disease. One thing that you need to be careful about if you're a researcher of a case study is that it's often a relationship will develop because they are extensively studied, and like in the case of HM, like it was over the course of years, the researcher became very fond of HM, very close to him, even though HM never remembered him from day to day. But when the relationship does form, it sometimes becomes difficult for researchers to remain objective in their observations and in their interpretations of them. Sometimes they want to like put the patient in a good light because they're fond of them, So the closer you become to a subject, the harder it is to be objective. And this is actually also true of ethnography. Ethnography is when a researcher lives within a group of people while observing and interviewing and studying them. So it's kind of like it's like let's say you're interested in tribal cultures, and you go live amongst a tribe, out in the wild somewhere, and and you may be spending months, and sometimes there's been observers that have spent years studying certain cultures or tribal societies. And one interviewer wanted to know more about small town USA, and he was from the city, so he moved up to a small town in the Midwest and just lived there for I don't remember how long, but it was like at least months and maybe even years, just to study them and write a book and record his observations. And so you live amongst them. Once again, this can be because relationships form and you're amongst them, you might start becoming less objective and taking the viewpoint of the people around you. Like it's hard to remain scientific when you like the people and then that you're observing and you get to know them well. Okay, that's ethnography. And finally, in video too, it's very important. Replication of results is an important. It's important to try to replicate results. It increases our confidence in our conclusions if we can repeat the research and get the same result again. Let me just kind of break it down in numbers a little bit here. When we find what we call a statistically significant result in biology, after doing study, it still leaves open up to a 1 in 20 chance that the result was obtained just by chance, meaning that the experimental manipulation actually didn't work, but it appears to have. So like, let's say I'm doing a weight loss study and the weight loss pill group loses significantly more weight than the placebo group. So I say, oh, the pill must work. Well, there's still up to a 1 in 20 chance that result was just a fluke. Now, here's the thing. If I do the same study again and I get the same result, it was once again statistically significant, I go from, a 1 in 20 chance that it was just a fluke. Now it becomes a 1 in 400 chance. So, I'm much more confident now. And if I was to do it a third time, it would increase to a 1 in 8,000 chance. I mean, like, basically, okay, must have worked, at this point. I mean, so we get more and more confident, especially if we can repeat the results and get the same statistically significant results. Okay, and that concludes video 2. In video 3, we will look at experimental research designs. Yeah, and that's what we'll look at. Okay, I'll see you then.